very good morning, good afternoon, and good evening, and a very warm welcome to each and every one of you who have gathered here to be a part of RedTeam Security Summit 2021. This is our last session for this year, and we have with us Mr. Walid Faour. He will be taking the session on the topic Oracle Hospitality RES3700. Mr. Walid Faour performs penetration testing for web apps, infrastructure, mobile and API, and vulnerability management. He has found several critical payment system vulnerabilities and have 2 CVEs for Oracle. One among them is an RCE affecting thousands of companies. He is also on the Hall of Fame for the European Union for finding a high security vulnerability. Apart from work, he shows a keen interest in security research, hacking electronics, lockpicking, CTFs, hackathons, and participating in well-known security conferences. Without further ado, I am grateful to welcome Mr. Walid Faour onto the stage. Welcome, sir. The stage is all yours.
Thank you. Thanks a lot, Camila. That was a really good introduction. Hello, everyone. I hope you guys are having a really good day. I'm also thankful for this opportunity for RedTeam Security Summit to be part of this talk. So it is a really good opportunity. So first of all, like Camila said, I think I don't need to go again about this. This is just a brief introduction about me. I'm a penetration testing lead at Al-Shaya Group. And like you mentioned, I do pen testing on API, infrastructure, web applications, basically everything. And I also show a lot of interest in other random things, I would say, like hackathons, pen testing challenges, hack the box, try hack me, all of these things that you guys already know. Random things like lockpicking as well, so a little bit about things related to physical security as well. So what's going to be our main discussions today? So this is a topic about Oracle Hospitality RES3700. So we're going to cover today a lot of things. We're going to briefly understand what is this software, how is it set up and its architecture, why did I do this research, and then how was it exploited, and so on. And by the way, if any of you will have any questions during the talk, you can ask in the discussion or in the Q&A as well, so feel free to ask anything. So this is our main discussion here. This is the CVE that I have discovered. This is an RCE in the Oracle Hospitality RES3700 product. This is CVE 20193025. As you see, it's a 9.0 score critical. And you're probably asking, why are we discussing a CVE that's actually 2-3 years old? Like this is 2019. Well, I think the impact that it has on a lot of companies around the world, I don't think even until this very moment everyone would have upgraded or patched his system. So that's a good heads up for everyone else to kind of patch his system or patch his servers to avoid this kind of critical vulnerability. And this actually I did in a 100-page research paper about this. I published it on my GitHub. Probably if any of you is interested, I can share this GitHub link with the POC scripts that I have written for this kind of vulnerability. The vulnerability affects all versions from 4.x all the way to 5.7 for this particular software. So we're gonna dive deeper into what this software is. Probably you have a lot of questions. What is this? What kind of software is this? So we're gonna cover this thing. So here, as you can see, also this is added to the exploit DB as well. So you can search for it. You can download the exploit as well. This is on exploit DB. So just a side note here, this software is used, like it used to be owned by Micros, a company called Micros, but then Micros got acquired by Oracle in 2014. So Oracle Hospitality RES3700 is an on-premises point-of-sale solution that includes functions related to restaurant operations and customer service. Obviously in these kind of environments where point-of-sale systems are used, we deal with sensitive customer information. The software isn't something that you can just download and use. You have to be a customer to get access to it. That's the thing that has been running. This kind of software has been running for years without any issues being reported. Back in the days when I was a tech support engineer, before I moved to cybersecurity, I used to install, configure, and troubleshoot this software. And this is, the research started when I shifted from technical support to cybersecurity. That's when I found this nasty vulnerability, I would say. So, can we identify the global attack surface? Like, how do we know who uses this kind of software so that we can use, so that we can see what kind of impact does this vulnerability have? Well, one way is just going to the Oracle website, checking the customer success stories page. They will make your life easy and give that information. We can see some company names mentioned above already, so that's pretty easy. You just go there, and then if you want to target anyone, they're giving you this information. So we can also use some websites that provide that information. Like in this particular example, we have HG Insights. It gives us a clean list of company names with all of their information in this particular example. It also gives a nice map in the US. This particular example is in the United States. Obviously, this software is used across the world. Here we can see me hovering over the state of California, and the number of companies there are mentioned to be 85. Obviously, I think there's a lot more, and to obtain more information, we can use OSINT or open source intelligence tools. They will provide much more information to us. So I think this research might be useful for pen testers out there and red teamers doing engagements with these kind of companies in the food and beverage and casual dining store. And we're talking sometimes really big companies. We're talking like Starbucks, Texas Roadhouse, Pinkberry stores, a lot of other international very big brands that use this software. So how did this research start and why? I had a feeling actually there's something really wrong in the software and was interested to conduct a research and make an exploit for it. And obviously the another kind of reason is obviously improving its security, because if I report this to Oracle, they will obviously patch it and this kind of nasty vulnerability will no longer be there. So that was the reason behind this, and we're gonna move a little bit to the architecture. So here's the basic diagram of how the system is usually set up. This is very basic. There are more complex setups that are mostly in drive-through stores, for example. If you have drive-through stores, the setup will obviously change. It might include, for example, kitchen display systems, bump bars, and so on. So the normal setup usually isn't complex, just point-of-sale system running Windows, for example. A lot of the times it will be Windows. A receipt printer, a drawer, all connected to a switch in the cabinet in the back of house, and then there's a server also in the whole setup here. Here, in terms of how the software works, we can see just here a configuration utility. Like I can give you an example. You, for example, enter a Starbucks store. You order something. Your order is punched on the point of sale machine and stored on the server inside the store in the back office area, I would say. The store manager usually performs all the admin tasks, like he checks the sales reports, he adds, edits, remove employees, checks clock in, clock out, edit items, among a lot of other things. In this screenshot, this is a POS configurator tool where the store manager or admin performs various admin tasks. So how was the vulnerability discovered? This is a simple thing. So to test everything, I've set up a virtual environment, just a server with the software installed, one POS machine with the client software as well that is running on the POS machine, and my laptop with all the required tools. And this basically simulates the real thing or the real setup. So the concept of discovering our bug vulnerability starts with a couple of questions, I would say. So I had in my mind, like, how does the server and client communicate with each other? That was my first question. If we find out how they communicate, can we replicate or replay or reproduce the communication and send our own commands? That was the next question. So here we see Micro's control panel. This is a utility. This is a small utility that allows us to control the POS machines from the server itself. So if you go to the server, you open this utility, and you see on the left the number of point of sale systems or workstations that are available in this particular store. In this example, in the screenshot, for example, we only have one point of sale machine or one user workstation. If we select it and then we click on reboot, then the point of sale system will be restarting. So that was pretty interesting to me, like what's happening in the background. How is it being restarted? Obviously, you can see it's being rebooted, and this particular POS machine was running an old Windows embedded POS Ready 2009 OS. By the way, in real environments, this would usually run on IBM 566 machines, but this is just one model that is usually used, IBM 566. So this was interesting to me. I mean, how is this reboot happening? Like I already mentioned in the background, behind the scenes, what's going on. Other thing that actually caught my attention is when you install the client software on the POS machine. So if you go to the POS machine itself and you want to start the installation process. So we have a POS machine that is completely blank. It just has the Windows. Now let's install the Oracle Hospitality RES3700 software, the client side of it, of course. So the utility will load and automatically detect Oracle Hospitality servers on the network. So which means once you just start the installation process, it will automatically detect, hey, we have an Oracle server in your network, and it detects its IP. You just select it. So once you select it, you just click next, and you have another options there. You will then select which workstation is this that you are installing on. Is this workstation 1? Is this workstation 2? And so on. So once that is done, what you will see is that you will see that files are being transferred. Like once you complete the installation process, then just a lot of windows will pop up, and you will see like files are being transferred. The system will reboot 3 times automatically by itself. And obviously that was another interesting thing to me, like how are these files being transferred? What's happening actually? So a pretty obvious step at this point to check the traffic is to install and use Wireshark to sniff the traffic. So I've tried rebooting one workstation from the server while capturing traffic with Wireshark. And then, I went through all the packets one by one, and actually I found what I want. First of all, nothing was encrypted, nothing was obfuscated, everything is in clear text. And we see here, it's actually using SOAP, pretty old, I would say, API. SOAP, it uses XML and so on. It's pretty old API. So here in this screenshot, this is like this happens when you just follow the HTTP stream and you see the request and response. And let's see, what we got here by just following the stream. So we see the server sends an HTTP post request to the remote POS machine on port 50123. Then we see XML structure in the body. The service is for the reboot method. Is called MDS sysutils, for example, and there are no parameters. And in the response side, the response is returning 0. So if we check here, we have a response between these XML tags, MRS environment response 0. This means the request was sent successfully. So in this case, it looks like over TCP. We have the TCP protocol over port 50123, and the client has a SOAP server listening for incoming commands. From what we've seen, it's a predefined XML structure and an HTTP post method. This is just the basics of how a reboot method looks like. So let's try to replicate this. Now, as long as we have the request or how it looks, we just copy the request we got from Wireshark and put it into burp. This time, let's change things a little bit. So we will try to send the reboot request from my laptop, right? I just opened Burp Suite on my laptop, and then I copy paste that request to Burp Suite. And instead of restarting the server, let's put the IP of some workstation machine. right? So we put the workstation there, and we got a successful response here on the right. Or actually, let's restart here the server. What I was meaning is the server, sorry. So let's restart the server instead of the workstation. So here we can see the server is being restarted. So that's good. But obviously, that's not enough. As I mentioned earlier, on the POS machine during client software installation, files get transferred from the server to the client. So I did the same thing. I installed Wireshark on a POS machine and launched the client setup process and captured all the packets. So this was a pretty big task, I would say, as I was trying to kind of discover all the API methods. So I just went to the POS machine, started punching orders, doing clock in, clock out, all kinds of things. Like every single button on the interface, I was just clicking on it, trying all kinds of things. I've clicked everywhere, tried to use everything, all the functionalities, and the result was incredible. First of all, this is how the structure looks like for a request. This is a basic structure for all the APIs that you see in the next slides here. So here I'm pointing out the main services that we captured. Each service will have several methods as well. So these are just the main services here. So for example, if we take the MDS sysutils service, we'll have a method called reboot to reboot remote systems on the network. It will have a lot of other things as well. So in the next slide, you'll see what I was able to capture. So here I'm kind of like making an API documentation of my own. So the MDS sysutils service will have the reboot method, like I mentioned, and then it will have a method called getFile, so to read and download files. It will have a method to transfer files, right, to replace existing files or write files to the remote system. I mean, from here itself, you can see this is pretty dangerous. Like even you can see, if you see the screenshot, we have reg set value, you can set registry keys, you can delete registry keys, and a lot of other things. So drilling down a bit more, here I've documented all the parameters as well, their format and response. For example, in the getFile method, we have the destination and file name parameters, and the response is the data parameter containing the contents of the file base64 encoded. So if you just imagine send this kind of request with all the parameters, you'll get a response back in base64. That will be the contents of the file you're trying to read on the remote system. So this particular screenshot and this particular method, let me tell you, it was really, really fun to test. I mean, I don't know how to describe this because if it doesn't matter if the printer has a network interface or a serial interface. You can send this request to any point of system, any point of sale system on the network, and it will print whatever you sent. So if you have a point of sale system and you have this request and structure, I tested this on my on my virtual setup, and I was sending all kinds of requests, and the printer, the receipt printer, was printing anything. So you can forge invoices, you can print a smiley face, maybe to the to the cashier working on the point of sale system. I mean, as hackers, usually they kind of, if they hack your system, you might see a smiley face being popped up on your system. In this case, it's just the printer printing that. That would be a little bit of fun to actually do. So I'll explain a couple of important API calls. Obviously, there is a lot. So by important, I mean they can do things like write files, read files, modify registry, and so on, which I already discussed. And the transfer file method allows any user on the network to write files remotely on any server or client with Oracle Hospitality installed without any authentication, which is the big problem. This particular example, this method takes 3 parameters as input: DST, which is the remote destination or location or path on the server or client; FN, which is the file name on the remote end, which has to be a full or absolute path; and then obviously the data, which has the contents of the file in a hexadecimal. In the request above, I'm sending a request to create a file called virus.txt with the text, "This is a virus," in this particular example that you see. So we can confirm this, as you can see, we can confirm on the remote server that we can write files indeed. Let's take a quick look at how we can set a registry value also. We just mentioned the key we want to modify, the type of it, and the key name and value. In this example, I'm modifying a registry value and changing it from startup false to startup true. So just to confirm that as an evidence, this is a screenshot before, this is a screenshot after, and obviously we can see it being changed successfully on the remote system without any kind of authentication. So let's first of all see what services are running on port, what service actually is running on port 50123 on the remote server, and what user is it running under. So from Oracle documentation, you can see here actually we have this kind of screenshot taken from an actual Oracle documentation file that is public and you can download it. So you see 50123 is running on TCP. It's running a service called MDS HTTP service. And if you go to the Oracle Hospitality server and then you look for this service, we can see it's running under local system, which is anti-authority system, which is which is great. If we get access as anti-authority system. So this is the test setup that I had, my laptop for attacking. So I had Kali Linux on it. And then I've set up 3 servers and a POS client on the same network. And this kind of presentation will focus on hacking the 5.4 version of Oracle Hospitality. I also just ran a quick Nmap scan to confirm that port 50123 TCP is open, which of course it is, so you can see here. And this is also, I would think, beneficial for any kind of red team engagement. So if you're doing any kind of red teams and your client is working in the food and beverage sector, it might be using Oracle and something like that. You might have already some kind of foothold inside. You're trying to do, lateral movement. So that would be a great thing. If you scan and you find 50123, just remember this talk, I would say. So what is the plan here actually? What should we do now? We should kind of chain all of these things together to get access to hack, I would say, the Oracle server, to get access into it. So the plan is we first of all use the transfer file API to write a backdoor program remotely to the victim or the server. Then we use the reg set value API. We just modify a registry value on the server. And by the way, this registry value, this is something that I've discovered. When you just start your day at a Starbucks store, for example, the first thing that an admin would do is he would, go to Microsoft control panel and then he would click front of house. If he doesn't do this kind of thing, the store will not operate. The point of sale systems will not operate. So what I've discovered in my research is that as soon as you click on front of house, there is this exe that is running under dmicros common bin run dbms.exe. This kind of executable will run as soon as you click on front of house, and it is actually defined in this particular registry location. So what I did is that I only just changed this value to the backdoor that I transferred, and that's it. So as soon as someone will click on front of house, it will be running my backdoor program. Now, of course, what I need to do is to use the reboot API as well. So I have to reboot the remote server. So obviously there will be some kind of disruption to service, short disruption. So the server will be restarted. Then the administrator will have to go to the server or the manager of the store and click front of house. And obviously we'll be having a Metasploit running a multi-handler listener, listening for incoming connections. So here you can see I've made a Python script that will transfer the payload, change the registry key, reboot, and so on. Right. So on the other side we have the Metasploit multi-handler listening. So as soon as you just run this exploit, it will do all of these things. And then, as you can see, here we go. We have the anti-authority system level shell with full access to the server running as anti-authority system. So thank you, everyone. If you have any questions, I will be glad to answer them in the discussion or Q&A. You can contact me on these contacts, as you can see. And thanks, everyone.
Thank you so much, Mr. Walid Faour. That was a wonderful session. I think audience got a lot of suggestions from your side and that is great. Like you have researched a lot on this, and truly amazing to see how passionate you are about what you do. Thank you so much. Thank you so much for being with us, giving your time for RedTeam Security Summit. And we are really grateful to have you, and we hope to collaborate with you in the future as well.
I'll be more than happy. Thanks to you, Camila. Thanks to the whole team. It was an honor to be here. Thanks a lot.
Thank you so much. Thank you.
Should I answer any questions now or? Oh.
Sir, can you hear me?
Yes.
Okay. So there was this one question, but okay, there is two questions in the question answer session.
Okay, I see
that. Yes.
Yeah, which tools you use to observe Oracle Hospitality daemon processes? Actually, I didn't use any tools. I think what you mean is the service that runs this vulnerable component. Like I have discovered, first of all, that my target is running port 50123 TCP. And from there on, I just went to Oracle documentation and I looked at, it was a pretty long PDF, I would say. But one of the pages, mentioned that port. I was just reading through it. I saw 50123 TCP and that was it. I just saw it. And then it was mentioning it is MDS HTTP service. So that was it. So for the Python script, yeah, I'll give that. 1 second. So I'll give you a link to the 100-page research paper that I did with all of the POC experts in Python. It will have more than enough resources for anyone to read. This is the GitHub link. It is open source. Everything is open source. So I shared it in the Q&A. Let me also share it here in the discussion as well. Yeah, okay, it's shared there as well. Okay. Thanks. I think that's it. Any other questions? I think yeah. The Python script I've already mentioned. Yeah. Please suggest any platform to learn about this. Actually, this kind of thing, to research, it's security research. You need to have a lot of background and a lot of other things like coding, Kali Linux system, Windows systems, a very diverse, I would say, background to do this. So there's no one answer to this question. I would say, just go ahead and learn whatever you can online, and that would be of benefit to you to conduct any research for this. In this particular example that I showed, I just used, Wireshark, then a couple of Python, skills, and that's it. Just common sense as well.
If you have any other questions, audience, you can post in the Q&A session on the right-hand side of the screen. So yes, we have another question.
So any learning side for exploitation development using. So for exploitation development, I think this was not, I would say, exploitation development in the full sense of the word, because I was not doing, for example, something related to buffer overflows, where I was, for example, bypassing data execution prevention or address space layout randomization or things like that. This is not related to operating system stuff, I would say. This is more of on the networking side of things. But a good resource would be Corelan. I think you guys know Corelan. You just go to that site and you can start from scratch learning about exploit development. A lot of other good resources online as well. So I think that's it. Camila, do we have any other
Yes.
thing?
If you have any other questions, you can post as soon as possible. Uh, I think that's pretty much it for the day. Thank you so much. Thank you so
Okay.
much, Mr.
Thank you.
Walid. That
Thank
was a
you.
wonderful session, wonderful questions, and thank you so much. We hope to collaborate with
Thank
you
you.
in the future
Thank
as
you.
well. Thank you
Thank
so
you.
much.
Thank you.
Thank you for your time. Thank you.
Bye bye.
Have a great day. So, audience, we have closing ceremony at correct 8:30 p.m. today, or you can go to the closing ceremony session as soon as possible. We'll be starting within some time. So, hope to see you all there, and hope you all enjoyed the RedTeam Security Summit sessions. Um, and it was beautiful 2 days, productive, informative, filled with passion, and hope you all enjoyed. So see you all at the closing ceremony as soon as possible. So thank you so much for being there with us, and making Red Team Security Summit a great success. So thank you so much, everyone. So see you all at the closing ceremony.